Garcia. I am a STEM ambassador and I work as a tutor and demonstrator in the School of Engineering at the University of Glasgow. I help out with tutorials and lab demonstrations for undergraduate and postgraduate studies, and a lot of those involve maths or applied maths. A lot of the engineering degrees, as well as many other careers, involve a good understanding of numbers, mathematics, statistics, and just in everyday life, you're going to find out that maths are really important just to carry out everyday regular activities in your lives. So for me in the university, helping the students with these courses involves basic first understanding before they can use maths and apply them directly in their degrees, such as civil engineering, mechanical, electrical, even bioengineers. All of these usually involves working with data, numbers, and from those, just as a researcher. So I am also a final year PhD student in the School of Engineering in Mechanical Engineering, with a little bit of electrical engineering as well, because my research and my project involves working with energy harvesters, which look into gathering energy from sources in our surroundings and using it to generate electricity. In this particular case, we use kinetic movement, and I'm trying to harvest the movement of humans, like walking, running, jumping, dancing, and just basic whatever movement you can think of that we can do, even machines, cars, just any kinetic energy that you see around you can be harvested and used to power electronics. In my case, I use the material that I have with me in this little case that I make into pellets. And those little discs, I'll show you one of them now. So this is what I end up creating. It looks like a little coin. It's really, really thin. It has some silver electrodes to connect to the wiring on both faces, and that goes into a circuit, so then I can connect it to a battery that then you can connect to small devices like your phone or a camera to charge as you go. What this type of technology would help with is basically allowing people to generate their own electricity. So areas where power and energy and electricity are difficult to obtain, this would be a matter of will and just humans wanting to create their own electricity. So they've had to move to generate electricity. This is an environmentally friendly technology. But just like this, many researchers in their areas will have to work with data, numbers, and from those, every time you do an experiment, you have to do it several times. And every time you do an experiment, you need to account for potential mistakes and errors. So that will give you the amount of experiments you have to do and repetitions. You then have to calculate the error to those measurements and average them down. So maths are really important for that, for you to get a more accurate, precise, and then that the experiment can be repeated and reproduced in the future if needed. So at least in my experience, both in my jobs as a tutor and demonstrator and as a researcher and as a PhD student in mechanical engineering, maths have been part of my life completely. Not only that, so as part of my research, I showed you what the final result looks like in the little coin, but I actually, for this to be able to be made, I need to weigh several different chemicals for me to create the desired material, which ends up being a ceramic pellet. So one of my little cases with chemicals is this one. As you can see, I'll just show you a little bit closer. It has several different vials with powders, and each one of them I need to put into a specific formula to calculate how many grams of each one I need to get the desired composition to get the results that I'm looking for. So in this case, even though my background in my bachelor is in physics, I actually use mathematics all the time as part of my research. Not only with those type of things, So making the material itself requires maths and statistics to know percentages and to put into equations to calculate how much I have to adjust, because also the purity of my material affects how much more or less material I have to add to get the right amount that I need for the specific composition that I'm trying to get. So once I have that, I actually need to use maths again when I'm testing the material for the specific properties that I'm looking for. So in this case, I'm trying to measure how much force is needed to then measure how much electricity or energy comes out as an output of the material every time I compress it. So then I need to use a little bit of physics for that, a little bit of like how much force is going into it, how much pressure, the area that's being applied into the material. So every time I do this, like I mentioned before, it requires me repeating that test several times so I can actually get a true value or something that is actually closer, and that is not just one time and it just ends up being an absolute truth. So you need, as a researcher, every time you do an experiment, you need to be able to repeat it several times. And for that, you need to consider maths, because that's going to help you do deviation errors, standard errors, any type of absolute errors. That's always, maths and physics for me have always gone and walked hand in hand. So, and an extra bonus for me was that part of my PhD had to do with chemistry. So you're gonna find that maths end up being a basis for just a base for a lot of the degrees and careers, and just generally in life. Absolutely, maths itself can be a path for you and a degree in itself, but you're gonna find out sometimes. I met people through my life that they've chosen a degree to try to avoid maths, and then they end up finding out that they're almost unavoidable, and there's a beauty to them. So I truly encourage you to ask questions and find a way to make them fun for you, because I can truly say that I find them so intriguing and so rewarding when you get to the solution and finding the right answer. So celebrate maths this week and all throughout your life, and yeah, let curiosity guide you. So I think that's me for now. I'm Veronica Garcia, and bye.